Hello, everyone. Today we have a new meetup related to security risk management. This is based on really huge materials. So that's why it's like a high-level overview in connection with a practical example, how it works and related to well-known practices. So let's start. If you don't know me, I'm working right now in Andersen as a solution architect. I've been here for 18 years now, played different roles and different teams and projects. So I suppose it gives me some kind of authority to speak about things. At least my opinion was based on the things that I did. So the agenda of today's meeting is introduction. Then I will tell you about some cases that I faced, why I did it. Maybe you will see something that's relevant to you. Then we walk through some fundamentals of security risks management. Then switch to risk management. Then go to security itself. The theory, the steps, and what I do, or what I propose you to do. Then I will come to example, the precise things that I suppose you also face that thing in your projects. Then we'll sum up and discuss the cases from the second section here and how I would approach them if I knew the things that I presented here. So, you know me, so I would like to meet you as well. Who is here like from the architect position? Great. And who is like manager, project manager, delivery manager, and developers? Right. Who's left? QA engineers, business analyst. Okay, I haven't guessed. Okay, let's continue then. I suppose for you it will be more technical things, but still, let's overview, and I will talk about security risk management from the human perspective. Because, like, you know, sometimes when we are talking about risks, not really everyone understands how it works, like from human logic. And I will tell you why. This is one of the key takeaways you will have from this meetup. The introduction. So risk management is about threats and how we deal with them. This is the main topic when we're talking about anything that we want to measure. And security is one of the key aspects of the solution we need to deal with. And these two parts, like threats and reducing risks, the actions we need to take, this is like the two main parts, and everything between them is something that we need to deal with. And why it matters, and why it matters even more right now in depth, like the methodology, how you work with that, is that actually we not developing just in IT sector of developing new software, but like people also developing new things, finding more vulnerabilities and find new way to approach people who are involved in IT sector. So the people themselves actually is one of the biggest part of the threat for IT. Then that's why it's growing. Then the more compliance things and regulatory is applying through the year, it's evolving as well. Now we see more things that come to companies, and more companies right now think about, okay, we need to deal with private information. We need to produce something related to medical device, the financial things. It also become more and more pressing here for companies that work all over the world. And like, let's say if we just try to imagine how people worked, let's say 15 years ago. Sure, there was some regulatory compliance things, but let's take a look to Asia and Africa. They are just starting doing things right now. And that's why it's something new for them, how they should approach the things. And of course, the system complexity is growing really fast. And yes, we can also say that the components we use and they reuse it again and again. but still the complexity of the whole system is growing dramatically. Previously, there was monolithic system that is enough for us. When the complexity and grows to the top, then we split it to microservices. We start using new components, integrating with existing system, which becomes more and more complicated. That's why it's not just growing in the scope, it's also growing in different aspects we need to consider. So the solution architect is the one who begins the system actually. Surely there should be some other people involved with that. I'm talking about business analysts and managers who work with clients, who work with people, stakeholders, trying to deal with all these things related to project risks, right? Financial things, and try to understand the goal of the system. Still, the first front line for the risks is the person whose work is more important in the beginning, whose work is not just important, but if you can do it through the whole timeline of the solution, even after it's released and go into production, but the cost of any change growing while you're developing things, well, the more you have in your system developed, the more it costs for you to change. Sure, there is approaches like microservice architecture, service-oriented architecture, hexagonal architecture. All these things allows you to minimize this cost, but still it grows. That's why solution architect is the first person who starts the system and needs to deal with the security himself, because he knows all the aspects of the process, not just the technical one. The cases that I show you related to the security is more for security itself, not just risks. As a developer, like 15 years ago, something like that, I started with applying particular security measures, like certificate HTTPS database encryption, something like that. That's actually, everybody should know, or they knew it from their managers or their tech lead. And later, when I become some kind of head of department, now I start working with checklists, right? So it becomes more and more known through in the internet, so I can check it if my solution is proper, done according to these checks. Still, it's just a list. So from the first, then I need to come to the solution, and maybe I need to check if they did things right. Audit is another way to approach the security of the solution. It's not mine, it's someone else who did it. I don't need to develop it. Then I need to prepare some vision of the solution that I won't even maybe start doing, right? But this is like a showcase. This is something that it is not applied to real code base. Even if we're talking about the solution architect is the one who is in the beginning, and it's more like a waterfall approach with some preliminary design phase, it is always the one architect who is really connected to the things that we implementing. That's where you should start doing things, but in that case, you don't deal with that. We are working with imaginable things. Then starting project from the scratch, just after discovery, or just I joined and I need to deal with the risk right now. And everything is fine except the last point. If I start doing with regulatory things, compliance, and it becomes more nasty and requires more and more paperwork. And funny thing, if you really hate this and try to automate with modern things like AI assistants, it will become much more easier for you to deal with. And then you'll find that you learn more from software security risk management and all these connections. You become not just software architect, but solution architect, and more to enterprise. And I will show you why. So the fundamentals. When we think about risks, the most thing that come to our mind is related to security, functional risks, maybe performance, right? So, but there are many There are so many different risks, there's so many different aspects because people learn how to build the system. And it's not just related to well-known things, but also project risk is that actually starts with that, and financial things that where we gain this knowledge, how to deal with it, not just simply threat modeling, right? This is more technical, but how people approach that. For sure, all risk management came from engineering. When people start thinking about what the parts of the system may break and the scenarios of that. But then it comes to IT, and the first people who get it was from finance sector, because they need to deal with money, which actually costs a lot if you fail. That's why things like operationals also matter. Maybe another one that actually solution architect can deal with, like the performance for sure, security functional, maybe, yeah, right? Compliance, why not? That's why I put it like close here, but everyone is close to security. Third party as well. It is also interesting. We tend to think about third party that it doesn't matter because we outsource that. But still the connection, the relation between components matters, because if you share private information, personal information with them, how we ensure that they will deal with it properly? So we need to check the requirements or put these requirements and enforce them. So they will deal with this information properly, and you need to ensure that they deal with that properly. Something like that. So let's say, for example, from architecture perspective, you shouldn't allow people to download file for users if it contains personal information, because once it's downloaded, it can be corrupted. It's out of your control anyway, and it's become the operation system, become the third party component that people deal with. So something like that, right? The quality, right? Managing risks as not just the word approach, but if you just simply remember when testers become quality assurance engineers. That's the transformation, when you just transforming from the person who try to break things to the person who actually care about the quality of the system. But the QA engineers are the first person you met who deal with risks. They don't care your system is written properly, they need to check. But the same thing is about risks everywhere. If you want to ensure you're doing things properly in every aspect that was presented on the, like 2 slides ago, the risk management is the way you can do it. I want to emphasize one critical things related to risks, and I frequently face the situation when people mix 2 types of risks, is inherent and residual risk. And people tend to think about security risk as a residual risk. I did everything. Like I am as a solution architect grown from development. If let's say I will imagine that I grew from a QA background, I definitely will start thinking about inherent, because like I don't trust anything. But as a developer, I trust my code, I wrote it, right? So now I applied everything, like all control matters. I have HTTPS, I have properly added authorization provider, I have encryption everywhere, and I don't care. Then people come, like from the joke about the bar, and it's just burned down. And they simply DDoS my solution, corrupt something, access snapshots, change something in snapshots, then it's the snapshot is replace it in DR scenario, and they get access because I haven't encrypted my snapshot. Why? Because maybe it's because I think it's in a trusted perimeter, but I cannot have trusted perimeter in cloud anymore. That's like the complex scenarios may come and the probability of them really low. But if they're low and everything else is closed, then probability grows. Okay, inherent risks before and they after. So inherent risks are theoretical, right? So residual risk is that actually everybody else like deal most of the time. While like it's mitigation in place, it's just by definition. And what go wrong in principle. So that's like you see what how QA engineers work or think about it the same, right? What possibly, while this is still go wrong in practice, this is another approach. And this is why it is important. Like this is design and modeling is something that you as a solution architect start dealing with from the beginning, even if you apply already control measures in automatically. You wouldn't design your system without, let's say, DDoS protection, right? Firewall, it will be there, but still, it doesn't mean the risk is right now is zero, because maybe you need to think about other stuff. And the trouble here is they are different, like a fire, but this is controlled fire in fireplace. Now it's like, it's still a risk. You may deal something better with that in the fireplace, but this is scary fire that burns everything. And difference lies in like what they do. So this is obvious. Like Captain Obvious came to our meetup, and people think that okay, we did it. We apply control measures, residual risks left, and like it's minor. This is well known because checklists. But this is a scary thing. People don't want to think about scary things. So that's why there is motivation come. Residual risk is minimal. We naturally want it to feel safe. But actually, this is human bias. We don't want to deal with that thing. And inherent risk, there are many. If you want to deal with security risk, registry, it comes to average 100 or maybe more scenarios, and this is really like combined view. It may grow even more because like there are many risks, and you will spend like approximately the same amount of time writing your risks and designing your architecture. Why I'm saying so? Just please check how much time you will put into writing code and writing unit tests on them. It's mostly the same. That's why we can do this. Like if just simply check the similarity, you may write functional tests on your code, right? It will. You won't spend too much time. You will check most of the things, and this is kind of how threat modeling works, or checklists. But it won't guarantee you that it covers everything. Control measures. After you applied everything, then most of the things you did is right. Some of them excessive. You don't need to apply, let's say, DDoS protection on you may need to apply to production, but you don't need to apply to, let's say, dev and stage, right? You don't need to apply, let's say, snapshot encryption in dev and stage as well, because they don't have any snapshots, because you don't need to pay for backups. But you still need to manage access. But for production, you simply restrict access for your dev team. And it's highly likely after you apply it automatically all control measures that something is missed. And I will try to show it to you and convince that there is something more you can do always. And like the pillars are well known: identification, assessment, and response. And I intentionally use this word because people tend to misuse mitigation here, but because mitigation is really cool word when you like, I mitigated all risk. Actually, you haven't, because there is 4 basic responses: avoid, mitigate, transfer, and accept. That's why there are many. Like if you Google in the types of response, there will be 9. So that's like a response. Then we'll switch to security, finally. And risk identification, this is the most complex thing from my perspective. The simplest one is assessment. consists of 4 parts. First of all is the source of security risk. We need to understand when it comes, where it comes. The second is threat modeling, because I still think this is really cool step. It is really needed. Then documentation. You put everything into the registry. You don't need to do this actually if you don't need to, but still this table may help you. And the review part, because everybody likes review if it's not done for you. If you're a manager, you like that your team is reviewed by someone else, and you don't like when you is the one which work is reviewed, until you understand why it is important. Then the source of the risk for architect, unfortunately, most of the time has to be user story, but it is not the right thing, because architects thinks in components, architecture, infrastructure, other stuff, which come to the second part. Why I put change to architecture? Because like we develop new things, and the things come, components introduced. We need to deal with new things every day, every change that come. And this is obvious that if you work in Kanban style, you do not introduce new architectural things before you approach the real story, real feature to do. You don't need to, let's say, introduce public object storage bucket until you know that you will store media files that is accessible through browser. Of course, the changes in non-functional requirements, if you believe that non-functional requirements exist. Generally, the trend nowadays that non-functional requirements just specific functional requirements, and you always see like people have the first epic. I really like this epic authorization and authentication. Actually, this is non-functional requirements. Was at least, now it's functional. I think like when we talk about availability, this is also become functional, because product owners, support teams start thinking, okay, we need maintenance windows someday, like in the weekend, and it becomes the functional requirements for your system, because they will operate it from the behind. Of course, the fourth one is it came from like my experience working properly with the code. When I have any incident in production as a developer, we have a hot fix. Then sometimes we did specific unit tests for that specific incident. And this is actually the same when you have the incident and you solve that. Maybe you want to deal with this risk and work with like it through the whole pipeline. The fifth one is actually touches 4 of them, but changes in third party is not something that is obvious. Sometimes you don't even track it, but still you need to pay attention what is changing, especially if you use SaaS solution integrated, right? So they will change, and you should know about that. So the support team or you practically need to check the terms and conditions, how they work. Threat modeling. I will try to cover these things, but I won't dive into that really deeply. Because I want to choose the most valuable things from the threat modeling, starting with the scope, threats, and countermeasures, which I found the most useful, because the rest of the part will be inside risk management. Why I'm doing this way? Because threat modeling is the core of dealing with security risks. But it doesn't mean that it's the only thing, it is enough. You cannot simply try to deal with risk like just writing the table. Otherwise, you will simply reinvent the wheel. So just go to things like, oh yeah, it will be the next one. Drawing some diagrams, right? So try to understand what components and data involved, what the entry point, how it interacts, right? The assets is more the things that like can be the target of the attack of this threat, and of course the trust levels and perimeter and everything that grants the access to the things, your assets. Then you may need to read the story. So this is kind of the guideline, the normal one if you don't want to use any AI assistant or something like that. Anyway, you need to do it. Or read your story, read your changes in your architecture part. Generally, then you need to use like well-known threads that is developed through the years, and they are documented, they evolving, like Stride, Pasta, and more things from this list. Stride is well known. Everybody should read it first when you deal with security risks. It shows how you can break the system, how malware or intruder may approach your solution. I personally prefer OWASP because this is the most modern thing. It's they work on that every 4 years. They plan to publish new version of OWASP. I think like in summer they have a better version in 2025, and by the end of the year we'll have this version updated. This is for the 21st, of course. And the documentation from OWASP I really recommend you to read. There are many, not just top 10. They have the same list for API threats. Really cool documentation related to file security, how you deal with files and objects. So this one is like for you to understand how your system can be broken. And of course, there will be countermeasures how you can deal with that. Unfortunately, they don't give you overview how the vulnerability is connected to countermeasures. And the reason is that the systems are different, and each system needs to have a special approach. Why I recommend to have countermeasures in identification step? Because sometimes you can find the what causes your this threat is when you have these countermeasures. It comes to the cause attribute, like missing components, missing measures, or something like that. So we will put it. It is not cool if you just simply put we have no and then countermeasures. Maybe you need to think through, because it may be much bigger than just that. Just, because we are human, we think in words. That's why you need to like put these words there. And risk description is much bigger than just in threat model. Threat modeling is usually scopes, assets, scenarios, etc. ID, of course, we all like IDs. Source is where it comes from. Component, we generally use components, right? It may be a feature. Why? Because sometimes you find that another data will introduced in the user story, right? So the architecture doesn't change, but you now see that not just personal information appears in the document, but maybe it's health information now is included. And then you need to deal with it differently. Potential hazard and the hazardous situation and the cause. Generally, people, it's really hard to understand sometimes, and from the beginning, what the difference is. That the cause itself, it's what you haven't done, and potential hazard is something that exists in our world, no matter we have this solution or not, right? And the scenarios is when you try to describe exactly what may happen. Sometimes you will like struggle with your imagination trying to put these words, so it's like a skill. The more you practice, the more you will have, but generally, I ended up with having standard scenarios. That's why I need to switch myself from this library of cases and start thinking about specific things of the solution. So there is somewhere in the middle, having ready scenarios and specific things of the like what you are working with right now. The harm is more related to the severity, but yeah, we'll touch it later. Owner, right? So this is really often when you see owners in risk registry, and I will emphasize this is the one who actually evaluated this risk, who can try to control the risk itself, but not the one who is responsible for solving that, right? Just for you to as an analogy, if we are talking about like QA, I'm talking about QA today a lot. This is the one who found this risk, found this bug, but not the one who will fix it. Okay, risk identification review. Why we need it? Like it is obvious, I think, because like there may be some misclassified risks, something like you did a mistake. Maybe there's assumption you made wrong, cause harm, something needs to be assessed here as well. The other thing is maybe there is something that you can check again with the libraries like OWASP again or something else. And of course, overconfidence is really, yeah. Maybe underconfidence as well, right? So when someone accesses, let's say, have elevation risks for your database, you may think that it will access just your data, but they may not just corrupt your data, but they first will grant access for everyone, and then it will corrupt even more. This is just an imaginable case. So sometimes we can double check it. And yeah, like refinement is always a good thing. If you understand, it doesn't mean that everybody understands the same way. Assessment is quite obvious, I suppose. We base our probability on these three things, right? Simply read them and try to understand how often this risk may happen. Severity is based on harm, of course. That's why actually how it differs from threat modeling. We don't think about this. And the last one, we define risk priority. And it may happen, like the priority is about management, right? This is your lever to talk with stakeholders. Because like the front line from the team perspective is like being technical advocate for the stakeholders, you, solution architect, and you need priority. And the priority is like that. You don't need to copy this table because like every project has different like approach, because risk is about the matter of your project, like what it does. If we're talking about things like parking application, car parking, right? Or let's say taxi, they will contain some personal information, but not so many. Even like people is allowed to store not real names, let's say, right? But if you're talking about a medical device, like fatal severity is risk 3 priority is mandatory. I personally prefer to name fatal as everything that related to either massive data access and corruption, application data, I mean, and infrastructure access, because it will cause further data corruption, etc. And critical mostly is about like personal information corruption, something like that, serious access maybe. So you will deal with that. So what does numbers and colors mean? R1, even if the threat model tells you like, this is a threat, it doesn't mean you need to deal with that. So this is what you can say always. This third is you should stop thinking about it and just do it, right? And the middle is you can negotiate, and now you can discuss approaches like risk-benefit analysis. If you won't fix it, what will be? Okay, I don't want to deal with that because like maybe I can introduce a user guide instead of doing the right approach, right? And then accept, like, okay, this is fine. Because we, as solution architects, we do not deal with budgets unless this is budget for infrastructure costs, right? Still, we need to negotiate with stakeholders. And then stakeholders come and say, okay, you cannot do it because you will be over budget. You cannot simply, let's say, install Sentry because it will cost you a lot. Of course, you as an architect would like to have it. Why not? Because you will deal with incidents much quicker than without it. But if the system is really simple, why should you do it this way? So you may think about these priorities the same way as the performance optimization for developers. Threat modeling deals with micro-optimization and do it like, okay, it is much better, do it this way. Of course, you can. But without benchmark, without proper tests, it doesn't mean that you did right thing. You may just simply overcomplicate your code to have some benefit that you cannot measure. This is why risks are, like, risk priority matters. Response. Response have interesting nature and interesting, like, relation with risks. This is where I always see when people from management come and they try to deal with risks very interesting way. They think that every risk have like specific mitigation strategy, of course, the mitigation as well. Nothing about acceptance of the risk. So one risk may have multiple responses. And we as architects know it, definitely. If you try to deal with authorization issues, you'll definitely deal with not just having authorization provider, but of course there is so many risks in JOT tokens that you also need to deal with, and then you have multiple responses. And if you start working with risks, and you may find another risk with the response and simply yet another risk that actually shares the responses. So they are many to many, which making them independent entities. An interesting part here that not just on this picture they are different. They come to different artifacts of your like project management, because this is a register that exists. It's like a pending, and this one is a plan. It's for engineers, and that's why I always recommend to separate them, because they have different entries. They track differently. One exists always, another one is have its own life cycle, and of course they have connection and different purpose, right? And moreover, you as a solution architect more interested in risks at all, and you don't care who will implement that, unless this is a DevOps engineer who will come to you and try to ask questions why you did this way or not. And they will say that them, you know, I did such big work, just please read manual first. This is register for you. Response description has its own like columns. ID, of course, action to describe the type. You may put even more. In the example, I will put more types because I like it more than just this four. You may prefer anyway, like the source, of course, which come from the source lab. You will need it when you need to convince someone why you need to do this or that. Like why you need to implement 15 minutes logout, right? Because the application is intended to use by anyone in a tablet, meaning that the user may be in cafe and simply left these things alone on the table and go to toilet, and everybody will access it. And they won't be trained unless you put specific measures to train it and check it, right? But this is something like I always have this discussion why we need to do this or that, right? Priority, yeah, sure, because like unless otherwise you need to come to the first table and check this priority. Owner, now it's owner who will responsible. Then this is like owner you always see in risk register table. This one is person who will actually apply the response. This is how you need to read the table. Like normally is written by managers or someone else. Documented, right? This is the cool thing. You don't need to stop on making your response plan as a description of how to do things and properly document everything. This is just like links, right? But you have lots of documents, right? You don't need to put everything here, but you have your own register, like architecture decision record, right? Maybe you have like architecture in one document. Of course, you may have like the process is described somewhere. The policy document is available for everyone, right? So this shouldn't be just in your risk description responses unless you want to bury it here and forget. And task, of course, there's like it's like a task, right? So it may have status, deadline, etc. And validation, yeah, it's really cool to validate if you did things right. So it may have like link to, I don't know, the security test report. Why not? If you want to be a cool guy and say, okay, we not just did this risk, but we paid money for specialized companies, so they check us, and here is the result. Of course, when you see this whole list, you may think that's really a big amount of work, and I told you in the beginning that it is big. Of course, you don't need to apply it in every project. Yep. But it's still like something that you can work on. Documentation is also another part, and then you will see why risk management is different from threat modeling. Of course, this is application architecture and infrastructures and platform. This is what we deal with. And then comes to functional requirements, because okay, when I want to introduce multi-factor authentication, I will put it there. And yep, development policies, we don't like to write them, but there will be mostly, in most cases, the only person who care about this is our solution architect, who write the things unless you have and your stakeholders, so product owners are rich guys and have the security officer on board. Tools and licenses, right? So you use something and you may need to add something more here. Software development plan, it's not like your roadmap, but your process description. It also may change after you did something with your security risks. Test plan, yep, the same thing. And support plan, finally, because your security doesn't stop when you release. It continues, and you need to deal with that as well. Because otherwise, why you put logs like and make audit? Someone should deal with that. And user guide, yep, this is not about solution architect, but maybe the one who speaks really smoothly and can convey the idea how to deal with things and like create video and say you shouldn't use your personal device when you're working with our application, because we won't allow you to use VPN or use it in a specific area. So you access it from everywhere, because stakeholders ask. So then you can deal it only with user guide and training materials. And of course, every change, as I said, is a source of the risk. So when you respond, then you will introduce change. You may deal with that like a residual risk. I won't encourage you to do that, because residual risk is something else. It's about the identification in the beginning, and like maybe there is something else left. But when you deal with risks that come from responses, that is just because you introduced new things like new buckets, new components, or new functionality. Let's say I have my medical device intended to be used by dentists only. And then my question is how I, as a security officer or solution architect, ensure that this is actually a dentist, but not just someone else. Of course, I either will introduce the validation process, like registration process that like come from admins. They will simply invite people, or there will be the certification, and again they will validate that this person who self-registered, then this person is the real one, but there will be like maybe certificates uploaded to the system. And this certificates has to be checked and stored because someone else will come to the system and say, okay, how we deal with that? Okay, we have certificates in our system stored, connected to people. And it just become for you available when you start thinking about the dentists and not just real person who can use, like not the only one. There will be many who intend to be like that. Maybe you'll think about dentist students they may also use, and then you have even much more troubles because they do not have certificates at all. Right. Example. Since I mentioned certificates as file, let's use it as an example. Because if your system hadn't dealt with any files at all before, it is always funny when you try to add this feature, and it will create so much troubles. Just because PDF file can contain malware. And our architecture in AWS may look like that before. Like quite simple one, I deleted mostly everything that is not related to normal flow. Maybe Cognito is, okay, I will put it there because files is also may touch the authorization part. And now I have object storage because I want to store my files in managed service. And this is my input resource for my risk identification. We'll try to think about scope, and it comes to components that actually now available in the system because data will pass all these things and come through them. And I start dealing with new type of data, which is just PDF file. Right, there will be some additional entries in the database, but this entries is just like a technical thing. So I may stop there because like PDF file now contains user personal data because it's certificate. Maybe some signatures, which is also really bad if somebody else accessed that and then they may copy them. And sequence, right? This is mostly like a scenario. I just put it there, so I see I outlined what is in my scope, in my focus when I need to deal with threats. So that's why I always encourage people to do threat modeling or even put threat modeling as a response for the risk that some risks are not identified before. So you can do threat modeling to deal with that. Also, then the threats is like that. It is 6 of them are quite well-known: malware, data exposure, broken access, not handling properly DDoS attack, and of course I like really much is logging about sensitive information, because if somebody accessed the logs, then they will know about your users and their personal data. I won't stop there a lot, and I won't stop a lot on other tables because it's really too much to read. And when you deal with risks, there is too much to read always. You may find these particular tables in the record of this meetup. Oh, it doesn't track on me. Oh. Yep. No. Okay. It catches me. Hello.
Now it's right.
Yep. So you'll find this in the record, so to read it. Then countermeasures is also another table. Oh no. You may guess why it's so small. Because it's too many things that you actually can deal with. And this is just because I added file. Sure, you may find that some of these things actually something that you always need to do, not just because of files. But yeah, most of them, like firewall, yeah, this is one is you need to have like sanitized logs. You also should have it most of the things, most of the times. But yeah, this is like just one thing that come to our system and cascadely creates so many other actions to do. And then I analyzed them, read it carefully, and try to put the risks together. and created a table with another color just to distinguish where we are. There are 5 of them. Sure, that's not 6. For some reason, it combined 2 threads into one risk. I would say this is the mostly based on the source and maybe potential hazard. I would say that you may find even more, but for the presentation purpose, it is cut by 5. More than enough to show you how big it may be if you deal with risks. And fortunately, they have different priorities. You may think that particularly the 4th, denial of service, may be a big one. I just put its minor there severity because I expect that there will be something, maybe it's not, but for the presentation purposes, it's R1. Just for you to see, I don't need to deal with this risk, just for that one. That's why the response part looks like that. There is nothing. I may put except here as a response and do nothing. And other things come here, and you now see that there will be training materials here, here, here. Oh, for everyone, like, yep, I need to deal with that. So it's not just infrastructure application. Then I need to deal with responses, right? So now responses here, like this should be another word. The bug is found. I put like monitor and prepare. Yep. Mitigation, avoidance. Oh, yep. Forbid inline rendering, right? I simply ask kindly not to render PDF until it's checked on backend. Because like if you are so brave to download malware PDF, please don't use it in our web application or mobile. So we'll care about that. Now, okay. Avoidance there as well. Forbid, like, oh, sure. It's in development policies. There is owner. This abbreviation come to be different people like solution architect, security officer, and other people you maybe know. Backend engineer, yeah. They are spread. Even if I am as an architect, the one who found these risks, I will delegate dealing with them to other people. Now it can become like that. This is the response for architecture and infrastructure. More buckets, more buckets like scan trigger and etc. And oh, okay, there is another microservice here because I want to minimize troubles that may happen if it's compromised or denial of service come. Yep, I think this is okay. No, just backend will deal with only clean and no way to access for sandbox. So I think DevOps should deal with this access and don't allow to access these things at all. Maybe sandbox for uploader, nothing else. Right, and I want to have specific logs that when the sandbox put, like antivirus put something to quarantine, I want to have something in logs. I think this is it for them. Yep, right. But this is not the only. There is a development measures, for sure, as I said, and we need to like sign it URLs with expiry, pre-sign it URLs, that's fine. Owner-based access, yeah, we don't like owner-based access, but because like I want to have just permissions granted, but not this thing. This is something that you start dealing with, or you need to do it the other way, like access just my files, and this is how this feature works. So and access every file, and this will be 2 features. Sanitize logging output, right? So you need to check it as a developer, and there will be some compliance tests because now I deal with personal information. I need to check it specifically. GDPR requires me to deal with that. Oh yeah, this is so bad. My risks doesn't contain anything related to stop processing my personal information. Oh God, I need to deal with it as well, but it is not listed. Sure, when somebody else delete it, I need to deal with these files as well. Functional requirements come. And other measures that involves other people as well. This is for BA to specify both requirements and access rules, and for security officer to do more things and prepare guides for involved people, because there is always residual risk. I incorporate them into responses because you may always start with infrastructure, right? And then start thinking about residual things left, like development policies. You can say people do not post anything to logs. You don't want to be the one who saying things time and time again. Just put it to policies and train people from time to time. And yeah, educate them. Key takeaways. Sure, threat modeling and security risk management is a process. We want to deal with that as a checklist, checkbox, but actually it is not. We as solution architects start that, and then we ended up with requirements for support process. It will never end until it's decommissioned. And then another solution architect come and create another application with many security risks. And yep, this is about relation, because your components is not the only thing that suffer from vulnerabilities. Like, they connected to each other. And systems have this property, introducing new things just because it's a combination of other smaller components. And solution for cases, right? When I do this particular security measure, I maybe, as a developer or the person who dealing with that, delegating, may escalate if I found something more that I do, like I apply HTTPS with certificates. Maybe I need to check what certificate I use. Is it symmetric? Or there's something not properly configured, where the certificate is stored, who provides that, etc. Checklist, that's fine, great. We can check other lists. Maybe we can create our own lists to check if it's fine. Then, of course, I maybe need to check for some residual risk there. When I do audit, this is the specific one, like stays aside, because I shouldn't assess the non-functional requirements, because they may say, we don't need security. This is fine. It will tell you why they haven't applied anything. But it doesn't mean that other requirements actually are okay with that. Then you may use it like that. And generally, you may assess the process of security risk management they do or do not, measures they have. And you may assess the residual risk that left. This is fine. Of course, DevOps will help you a lot, because either you will be the one who dive into cloud or infrastructure on hardware or Kubernetes they have, or there will be DevOps who check all configurations, how it is done, infrastructure as the code, etc., etc. When I work on architecture vision document, I generally use library of risks I developed through time, and check if it's applicable or not. Why? Because it's really hard to first deal with something that doesn't exist. The second, this investment won't return. You will do something, next day the documentation become outdated. So you can use it as a basement to like understand from the beginning, but it will be obsolete in 1-2 months. For the project, yep, you can work with risks, right? So I wouldn't recommend to write so big and complex things. You may work with risks you may work not with risks here, but with responses mostly to check them. And these responses become your architecture decision records, like why you did it. So you may put them there and forget about managing these complex tables. But if you're dealing with medical device or anything that have really heavy compliance things, then you definitely will require that approach, because it will ensure that you develop things with high quality. This is it. And this is not the only presentation I have. There were many other things presented here. And if you haven't subscribed to our channel or haven't been here, please come to our channel and see these things recorded. And there will be more things if you want me to present it to you that I know. I will be gladly share with you what I know. And hopefully the screen won't fit things that I actually can share, right? They may go outside and be posted on this wall. And thank you. While you're thinking about questions, if you have one, you can use this QR code to check what we have in our company, share your feedback, say, I have really bad English, or saying too fast, or simply do anything else, like be familiar. And this is for you just to remind what we just talked about. Please, your questions if you have one. And maybe there will be something in our live. Could you please check if there are any questions in the chat, if there are any? I cannot do it myself. Okay, we'll check, please. Yep.
How are we going to respond to the increasing number of chats between the AI?
Right. AI is.
I didn't see in the presentation why they.
Yep.
We concentrate purely on the security part of it. Now there's a number of opportunities for the hackers and threat makers to do them easily, and you could not rely on some implementation of policies on these participants.
Right. So I would answer it from my experience of medical device. Once you have a component that produces data based on AI, you should put your own requirements to that, like what it should be, the quality of this data. You should stop thinking about its AI or something like that, but you design things and you see, okay, this is requirements. And then you need to check if these requirements can be fulfilled by AI or not. So if it's like, can generate trusted data, not. So you can change your design, maybe you put other requirements. This is the main thing for me. The other is, of course, if it produces data or it deals with do things, it generally acts as the person, human. So you shouldn't trust human in security as well. But it's even less trustworthy than human because it makes mistakes a lot. So that's why we just approaching the era of AI threats. Then there will be research, I suppose, and mitigations for that. So I suppose we will be pioneers here. But from my perspective, you shouldn't trust this data anyhow. You should regulate it and put to sandbox, check by human, check by other measures, maybe another AI or something like that. Anyway, this has to be presented with mark that this data is generated by AI. Otherwise, you won't guarantee with the high quality of that. The second thing is tests, of course. The same thing that happened with performance testing, like performance optimization. There were not benchmarks back in the days, like 20 years ago, something like that. So they did, of course they did, but on really low level hardware, there should be tests for AI as well, right? And test cases to check if it works this way. And the third level is incident response. Like has to be has to be logged everywhere. So you put this data into logs, so you will automatically react on any incident that comes as fast as possible. So this communication has to be logged somewhere. What else can be done? Yep, I think logs are really important here because AIs tend to not leave anything behind, so they do and forget. That's why it's your responsibility to trace what they were asked and what they respond in the end. I hope I answered the question. Anything else? From management perspective, developers? Nope. Okay, then it's done. Thank you. And yep. Hopefully the life will be stopped soon. We expect pizza. So,
Thank you for coming. Stay for pizza.